Now that we've made our selection of cells that have at least 100 cubic meters per hectare of saw log volume and are within 250 feet of this road, we want to turn every one of these into a single, potentially operable block. And we want to generate statistics of total saw log volume, or total gross merchantable volume, or other attributes contained in this data set. We have a three-step process. We are first going to dissolve these to create contiguous units. We are then going to use a negative value in a buffer to bring those boundaries back in just far enough that their edges are not touching any of the cells bordering this area. And then we are going to join by spatial location to give the whole block the average of those pixels that fall within here. So our first step, geoprocessing dissolve. Input features is the forest inventory. And the only thing we need to change is uncheck create multi-part features. Okay. That has created this EFI dissolve. We can turn off forest inventory for now so we can see what we're doing. And every one of these has its own feature ID. Every one of these is a separate, potentially operable block. Now our next step is to create a buffer so that we reduce the boundaries just a little bit so that their edges are not touching the adjacent cells, so that when we ask for overlapping features or features that intersect with this feature, we don't get those that share a boundary. So geoprocessing buffer. Our input feature is EFI dissolve. And we're going to enter in just -1 meter. -1 foot would work as well. Okay. So now we have this buffer that is just barely narrower than the original feature. Our last step is to join this to the underlying polygon data by right-click, Joins and Relates, Join. We are going to select the underlying forest inventory. We're going to keep the first button checked. Each polygon will be given a summary of the numeric attributes. And because our attributes are all per hectare values, we are going to take an average of that. And then we can multiply that average by the number of hectares in each block, so that we arrive at a total for each block. Okay? That generates a new layer. If we open that attribute table, we'll see we have average for every one of the attributes that we have in our inventory layer. Average saw log. So let's go ahead and create a total saw log volume for every one of these blocks. To do that, we need a number of hectares for each one of these. So let's create a new field. So click here on the drop down, add field. And we want to have type double. We're going to call this hectares. Okay. And now we're going to right click on the header hectares, calculate geometry. And we're going to calculate the area in hectares. Okay. And that's how many hectares are in each one of these. Now, add another field. We're going to call this one, also type double, saw log T for total. Okay. So now we are going to multiply the volume in saw log per hectare by the number of hectares. So right click on saw log, field calculator, saw log T equals average saw log times hectares. Okay. And here is the total saw log volume in cubic meters for every one of these blocks. See, in the real world, of course, we would combine many of these blocks into operational units. But for our purposes right now, we could go so far as to label each one of these with its volume. Go to the Labels tab, check the box, Label Features in this layer. Total saw log, OK. And now we have, with a ridiculous number of decimal places, the number of cubic meters that we can expect to harvest from every one of these 20 by 20 meter cells.